classification of matter. So, matter. Right, we need to classify matter, how it's made, not how it's made, but how we talk about it. Right? How do we talk about it? So first we got to define it. So what is matter? Matter has mass, occupies space, right, and has physical properties, such as if it's a solid, liquid, gas, color, density, melting point, maybe a boiling point. So that's what matter is. All right, and we can classify matter into two basic or two classifications. All right. First is a pure substance. So pure substance. What's a pure substance? Well, that can be broken down into two different things as well. We have elements, right? Elements, that's the periodic table, right? Which are composed of atoms. And there are currently 118 different elements. 118 different elements. And with the elements, they cannot be decomposed into simpler substances by chemical means. That means I cannot go into a Gen Chem lab or organic chem lab, some type of chemistry lab, and mix some things, heat some things, and break down atoms. Now, there is a whole field of nuclear chemistry that does, split atoms or combine atoms or whatnot. That's not what I'm talking about, right? The sun's powered by atoms combining. A lot of nuclear power plants use atom splitting. All right, and so that's you're decomposing, you're changing the atoms. But that's nuclear chemistry, and that's not something you would do in a laboratory. Okay. All right. Okay. So the atoms, we can't just go down and break up nitrogen atoms from the air, or we can't break gold atoms down. All right. So those are the elements. And then we also have compounds. So elements, being the building blocks, can make compounds. And these are two or more atoms or elements combined together. All right. So those are two or more elements combined together. Now, those are pure substances. So what are some of the examples of this? So atoms, for example, O2 is an atom, He is an atom, Fe is an atom, right? Compounds would be something like water, H2O. You have carbon dioxide is another common one people know, right? Sugars, C6H12O6, or C12H22O11. Right? Those are some compounds we know. All right. So compounds, elements. Another one, NaCl. Not Na. Sorry. How about CaCO3? So I have water. There's water, salt, table salt, and limestone. right? I can mix those three. If I have those three together in a mixture, so we have water, table salt, and limestone. I can mix those three together in a mixture. And there's two types of mixtures. There is the heterogeneous mixture and the homogeneous mixture. All right, so what's the difference? Well, these guys, water, table salt, and limestone, right? If I mix those together, right, you wouldn't. Limestone's not really soluble, so you wouldn't actually have a nice solution. You would actually have a heterogeneous mixture, right? If I just had salt and limestone together, it's definitely a heterogeneous mixture, which means there are different phases evident. So if I put in NaCl salt plus CaCO3, right? I could even throw in sand, SiO2, right? Sand. And that's a very good heterogeneous mixture, right? You can see, salt and pepper would be another one. Okay. Homogeneous mixtures are solutions. And these have the same properties throughout. Right? It's a mixture at the molecular or particle level. Right? And so this would be like H2O and NaCl, salt and water, table salt and water. Right? So that's the classification of matter, right? It can be either a mixture or pure substance. Now, it's very important that we note that we can physically separate mixtures into pure substances. Doesn't matter the type of mixture. So if it's a solution like salt and water, in fact, we do this all the time. If you wash your car, some people don't wash their car, some people wash their car a lot, and in between. Right? When I didn't have kids, I washed my car almost every weekend. Now that I have kids, I hope to get to it once a month. Right? That's just how it works. And so, the homogeneous mixture of salt and water, like because your tap water it has some dissolved salts in it. So if you wash your car and don't dry it, the water that drives, right, the water evaporates, it goes away, and yet there's this white film left over, right? That's, some people call them water spots or whatnot. Those are the leftover salts that were dissolved in the fresh water, right? So that's one way to separate it, right? Distillation. There's right, you could actually, if you had, M&Ms, for example, if you're separating M&Ms or Skittles and make all the red ones to one side, right, you could physically do it. You could filter, there's other ways to separate compounds, but you're not changing the compounds, right? Okay, pure substances are harder to break down. Okay, so if we go to, if we look at an example here, if I have some elements, color, H2 plus, I'm going to use 1/2, O2 going to H2O. That chemical reaction. Hydrogen is a gas, so that's it. We put a G down. Oxygen is a gas. Water is a liquid. All right. Although I wanted to use, yeah, there we go. All right, so we have elements. We have a compound. And they're vastly different, right? So this compound has its own set of properties, right, that are unlike the properties of its constituent elements. All right. And so we have hydrogen and oxygen, right? If you had a bucket full of hydrogen and oxygen and you threw a match into it, it would explode, react very violently. If you have a bucket of water and you throw the match into it, the match goes out, right? These first two are clear, colorless gases, hydrogen gas, oxygen gas. They're clear, colorless, odorless. Sometimes hydrogen tickles your nose a little bit, but it's really an odor. It doesn't have an odor. And then water, of course, is a clear, colorless liquid. So it's totally different properties, all right? And so elements, compounds, and this is where we're getting to is we use elements to make compounds, compounds to make other compounds, and go on from there. And so we need to know how to classify these things.